Now we're going to still talk more about functions and graphing, but focusing on linear equations and linear functions this time. So graphs that are specifically lines instead of looking at curves. So a function whose graph is a straight line is called a linear function. And all equations of the form ax plus by equals c are straight lines when graphed, as long as a and b are not both 0. So it just means that you have to have one of the variables there. Such equations are called linear equations in two variables. Now, I do want to note that linear equations can be arranged. So for instance, one example of a linear equation in two variables is 300x plus y equals 1800. However, we often have them in different order, or the variables in different order or different sides of the equal sign, and that's okay too. So one of the common things that we tend to do is to solve for y in our linear equations. So if you have it as y equals instead, bringing that 300 to the other side using subtraction, that's still a linear equation. So what you really want to notice here for your linear equations is that you don't have any squares or cubes or fourths, so no exponents here. Nothing weird going on, like there's no square roots, there's no absolute value signs. You can have regular fractions and regular decimals, but we don't divide by any variables in these examples. We don't multiply the x and the y together. So they're pretty as simple as you can sort of get for an equation in two variables. Now, we can still graph these using the regular plotting points technique that we did in the last set of videos, right? So we actually did it with a few examples there with the lines as well. So you can still use plotting points to graph, but there's other ways that we can graph as well. And another way is using the intercepts. So the point at where you cross the x-axis is called the x-intercept. And the point where the graph crosses the y-axis or intersects it, doesn't have to cross as long as it touches it, is called the Y-intercept. And we can find these pretty quickly by plugging in zeros. So to locate an x-intercept, what you do is you plug in y equals 0 and solve the equation for x. And to find the y-intercept, you can plug in x equals 0 and solve the equation for y. So we kind of like intercepts, one, because there's a lot of applications that you can do with finding those zeros, but two, because they're just easy, right? It's easy to plug in the number 0 because part of your equation always cancels out. So we do tend to like intercepts. Now, you may still get fractions and stuff though. So that's the only thing when you're solving with points, is you have fractions too. So doesn't mean you won't get fractions, but they're still pretty easy to solve. So let's do our intercepts. So for your x-intercept again, you're always going to let y equals 0. So I'm going to take my equation here, and I'm just going to go ahead and replace that y with 0. Now, 2 times 0 is just 0. You're always going to get something that cancels out. And then if I keep solving, I just have to divide both sides by 3, and I get x equals 2. So my x-intercept here is 2. Sometimes we'll put that as a point, so it would be 2 comma 0, because again, it's always x comma y. But you'll see it said both ways. So your book kind of tends to refer to just the number as the x-intercept. So they'll refer to it as the x-intercept is 2. Some books will tend to want you to use the full point and say 2 comma 0. So kind of both ideas are used interchangeably. So when you're reading through or looking at homework questions, just see if it specifies if it wants it in one form or the other. If it doesn't specify it wants a point, it probably just wants the number. And then for your y-intercept, we can do the same thing, but we plug in x equals 0. So I go back to my equation. I plug in 0 for x. Again, that's going to cancel out because 3 times 0 is 0, and then I just have 2y equals 6 left. And I divide both sides by 2 to get y equals 3. So my y-intercept here is the point 0 comma 3. But again, sometimes we'll just read it as 3. If you want to, you can still make a table here. So I know I tend to like to do tables. So for the x-intercept, we were plugging in y equals 0 first. And then when we solved, we got 2. And then for the y-intercept, we plugged in x equals 0 and we solved to get 3. So if you find that helpful, you can still go ahead and do that. So let's see, 1, 2. So there's my x-intercept. That's the point that crosses or lies on the x-axis. And then for y, it's at 3. Now, these are linear functions, so all of our graphs are going to be lines. And you actually only need 2 points to graph a line. More is always good. So if you want to check by finding extra points, you can. You just want to be careful on the homework. If my math lab asks you to graph in a specific way, like using the intercepts, then you want to make sure you give them those points. At home, you can always find extras just to check your work, but make sure you follow the directions in my math lab because a lot of times they may specify what values they want you to use. So you want to follow those directions there. Now, another important concept with linear equations would be slope. So the measure of the steepness of a line is called slope. And what slope does, it compares your vertical change, so what's happening in an up and down direction, to your horizontal change, so what's happening in a left to right direction. And oftentimes you'll hear this as rise over run for shorthand. So rise meaning the vertical change and run meaning that horizontal or left to right change, to see how we're moving from one point to another. So you have your formulas here for slope. There's different ways that we can think of it. And then to use these formulas, you basically just need 2 points. So these little notations of 1 and then 2 just mean 0.1 and 0.2. So your first x and y value and your second x and y value. It's not really anything more than that. We call this formula either change in y over change in x. We can call it rise over run, or more specifically using the points. What we do is we subtract the y values up top. So we look at that change in y, and then we subtract those x values down bottom. That little triangle actually is called delta. It's a Greek letter, and we typically use it to mean change in mathematics. So we're just subtracting our y values and subtracting our x values to see that ratio. So what's happening vertically for the y's and horizontally for the x's. We tend to use m here for our formula for slope. So let's find the slope between these 2 points. Now, it doesn't matter what you call 0.1 or 0.2. It doesn't matter at all. What does matter is that you're consistent. So whatever point you start with in the numerator, you want to make sure you start with the same point in the denominator. If you don't, then you'll get the wrong sign. So here, if I start with this point in the numerator for my y's, I'm going to do 4 minus, and then this y is -1. Then for my x's, I have to start with the same point. So just start with the same point both times and you'll be fine. You do want to be careful. This formula has subtraction signs in it. So you have a subtraction sign here and here, and then we just happen to have 3 values that are negative. So a lot of times students make mistakes on the negatives, so just be careful. Now, negative and a negative here become a positive, so this becomes 4 plus 1, which is 5. And then here again, negative and a negative becomes a positive, so this becomes 2 plus 3, which is just 1. So our slope here is 5. Now we'll do the same thing for the next one. This is a good time to pause the video if you want and just try it on your own first to see if you can get the right answer. Again, I usually just stay in order and call one of them 0.1 and one of them 0.2, but it doesn't matter. You do need to do your y's on top though. So I'm going to start with -2 minus and then 4. And then for my x's, start with the same point. It's going to be 2 minus, and then my x value here is -3. 2 minus 4 is -6. Here, my negatives will cancel and become a positive. So I have 2 plus 3, which is 5. Now, if you want to take it to the next step, you could graph these too. So I'm not going to do any fancy graphs here, but just kind of real quick, -3, -1 would be about right here. And then -2, +4 would be about right here. So again, I'm just kind of doing really quick graphs. So you can see our line is pretty steep. 5 is not a huge number, but relatively large. So you just see this kind of steeper line. And then over here at -3, 4 would be about right there. And then +2, -2, about right there. So you have this line here going down. Not as steep, so 6 over 5 is only 1 1/5, so it's a smaller number. You're going to see patterns with your slopes. So the larger the absolute value of the slope, so meaning like forget about the sign for a second, just look at the number itself. So the larger the number, 5 versus 6/5, the steeper the line, the more vertical it becomes. The closer your slope is to 0, the flatter it becomes. The other thing you're going to notice is that when your slope is positive, you have an increasing line. And when your slope is negative, you have a decreasing line. And we always read graphs from left to right. And I have that summarized here for you. So for instance, if your m is greater than 0, so it's positive, then your line is increasing somehow. It could be steeper or less steep, but it's still going up from left to right. If your line is negative, then you're going to have some sort of decreasing graph. If your line is equal, or your slope is equal to 0, then you actually have a horizontal line. Which kind of makes sense, right? Because there's no, not that there's no slope, but the slope is 0. If the slope was positive, it would have to be going up. If the slope was negative, it'd have to be going down. So what's in between positive and negatives? Well, 0. So you can see that it has to be flat then. It can't go up and it can't go down. So it's that perfect flat horizontal line. And your last one is if your slope is undefined, what you have actually is a vertical line. So with an undefined slope, what you're going to see when you're using this formula is your denominator, your denominator is going to be 0. And we can't divide by 0. That's undefined. We never divide by 0. So for your vertical lines, when you're trying to do this formula, you get a 0 in the denominator. So it's undefined. And it kind of makes sense because with a vertical line, is it increasing? Is it decreasing? It's really hard to talk about which direction it's going in. It's straight up and down. So we just kind of leave it as an undefined notation.